Hello, this is Noor Jannat. Today I am going to share a project that I recently worked on as a part of my graduate rotational internship program. This is the first task. It is about prediction of student percentage using supervised machine learning. Let's see what I have done in my work. At first, I have imported some libraries, and then I read the dataset and stored it into a data frame named variable as a data. Then uh, here is the first of 5 observation from the dataset, and the dataset has 25 rows and 2 columns. Here are some basic information about the dataset, and then I have checked is that the dataset have any null values. The dataset has no null values. Here is the short description about the dataset, which contain mean, standard deviation, minimum values and maximum values and quantile values. Let's check the outlier in the dataset. At first, I stored the first quartile value in the Q1 and the third quartile value in the Q3. And the value of Q1 is 30 and Q3 is 75. Then I calculated the interquartile range, which is 45, and I used this interquartile range to calculate the lower limit and upper limit. The lower limit is minus 37.5 and upper limit is 142.5. Then I checked for outlier if any observation or student score that is lower than the lower limit and upper than upper limit, then it will consider as a outlier. But there is no outlier in this dataset. Let's visualize the dataset. Here is the box plot for study hour and score. The smaller one represents the study hours and the larger one represents scores. And this yellow line is representing the median value. The next one is scatter plot, which describe that the correlation between the study hours and the score is positive. And here is a heat map, which shows the correlation value is 0.98, which means they have a strong correlation between them. Then I stored the feature values hours into X variable and target value in the Y variable. Then I splitted data into train test. Here the test size is 0.3, which means 30% data will be used for testing the model, and rest of the 70% will be used for training the model. The training data consists 17 observation and the test data consists 8 observation. Here are the training data and here is the test data. Here is the target values for training data and here is the target values for test data. Let's build the model. As we have seen that they have a strong correlation between them. So I used linear regression to build the model and fitted the model with the training data. This value represents the coefficient of this model, and this one is intercept of this model. Now my model is ready for predicting the students score based on their study hour. So what will be predicted score if a student studies for 9.25 hours per day? My model says it will be 94.342%. Here are the predicted score of the student for the test data. I used a data frame for visualizing the original and the predicted score. So this data frame represent it, and here is a scatter plot which represent the training data, the model, and this one represent the test data of the model. Let's do some model evaluation. As I used regression, so I used mean square error, mean absolute error, and R square for evaluating this model. The mean square error value is 31.556 and the mean absolute error is 5.44 and the R square value is 0.894. So this is all about my work. If anyone have any queries or feedback, then let me know, and best of luck with your prediction.